Good afternoon, ladies and gentlemen. Please allow me to moderate this parallel session B. I am Kiki Cornelia Sari Sembiring. In this session, we will have 6 presenters. They are Mr. Haryadi, Mr. M. Rizal Mahidin Tambo Esai, Mr. Adit Adep Widyatmoko, Ms. Yani Meliana as a representative of Mr. Irawan, Mr. Egi Agustian, and Ms. Christina Wahyu Kartikawati. I hope all the presenters have joined this room. So today we will be assisted by Mr. Asa to play the presentation video. And if you have any questions during the presentation, just drop your question in the chat box. We will divide in 2 sessions. So after 3 presenters, we will have discussion session. And after that, we will continue to the remaining presenters. Okay, we will start it now. Please, Mr. Asa. The first presenter is Mr. Haryadi. Zinc oxide nanoparticles from zinc carbon battery, size control by alteration precipitation routes.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Well, I'd like to say thank you to the organizing committee allowing me to give a presentation. This afternoon, my presentation with the title, The Effect of MLM Activating Agent in Zinc Oxide Nanoparticle Synthesis from Spent Zinc Carbon Battery. My name is Haryadi. I'm from Chemical Engineering Department, Politeknik Negeri Bandung. So the outline will be covering like introduction, experimental, results and discussion, and also conclusion. So here, this is an example of the zinc carbon battery. It's a type of the dry cell battery actually, and it's widely used in different applications in household especially. And of course, this is the non-rechargeable battery, yeah, and then it difficulted when discharged. And the consequence is that the element inside will undergo a naturally leaching and deep into the groundwater, and it can change the pH and contaminate it. On the other hand, if we look at the inside of this part of the spent batteries, it contains a significant quantities of metal, such as zinc, that can be potential as the raw materials for synthesizing zinc-based compound like zinc oxide. As we know that zinc oxide is a unique physical and chemical properties. It has a high photostability, high chemical stability. It has a direct band gap about 3.37 electron volt, and it's also having a binding and excitation energy about 60 millielectron volts, and it's even larger than other structures. And if you look at the nanoparticles up to 100 nanometers, for instance, including their application, and we compare with the microparticles, of course, of research and have been carried out in order to obtain this kind of nanoparticles due to the outstanding characteristic, like mainly originating from finite size effect, and also the most important one is the high ratio of surface to volume. Zinc oxide nanoparticle, as we know, that is semiconductors. It also has been used as a pigment and coating. even in the UV shielding materials, photodiodes, solar cell, sensor, catalyst, or even in ceramic and concrete. There's a lot of variety of the methods actually that has been devised, like vapor deposition, precipitation, salt gel, hydrothermal, and as a consequence is that a different synthesis method, of course, will lead to the different particles, structure, and size. And the low temperature with chemical process also interesting, such as hydrolysis, precipitation, and hydrothermal, because they are cost-effective and scalable. Particularly for the precipitation, for instance, it can obtain the product with the repeatable properties for zinc oxide nanostructures. Therefore, in our study, we use this kind of approach in order to obtain the zinc oxide microparticles. And also we put capping agents to control the growth particle size in order to obtain the zinc oxide nanoparticles. If we look at the experimental here, that how we obtain the zinc oxide microparticle and zinc oxide nanoparticles, let's see in the left side here that once we dismantle these spent batteries, we just took and clean up the zinc anode part, and we cut in small pieces here, and then we react with nitric acid in order to obtain the zinc nitrate solution. And then we could neutralize up to pH 7 or even 8 by adding sodium hydroxide in order to obtain the zinc hydroxide as a precursor. For obtaining zinc oxide microparticle, we just separate it and then wash the product with distilled water and ethanol and drying in the oven at 105 degrees centigrade until a constant mass to obtain the zinc oxide microparticle. On the other hand, for the zinc oxide nanoparticles, once we obtain zinc nitrate, and we neutralize with sodium hydroxide in order to have a precursor zinc hydroxide, we also add amylum as a capping agent to control the pore size, the particle size and structural shape. Once we mix, and then we separate it. We separate using centrifuge, and then the product was washed with distilled water and ethanol, and then we calcine at annealing temperature of 400 degrees centigrade for 2 hours. And then once we get that zinc nanoparticles as shown here, both materials were characterized by scanning electron microscope XRD and also Fourier transform infrared spectroscopy. If we look at the result here, so in the morphology observed by scanning electron microscope, you can look at here the left side. The zinc oxide microparticle shows the irregular shapes, such as like flakes. These characters are also found by Rizender and his co-workers when they prepare zinc oxide microparticles. On the other hand, for zinc oxide nanoparticles, showing the spherical shape, and is due to the influence of the capping agent as well as the calcination step. The particle size, especially for the zinc oxide nanoparticles, we try to observe by using software, and it was obtained in the range of 80 up to 110 nanometers. And this is also appropriate with the finding by Anggiana and Prayoga research that the particle size in between 80 up to 120 nanometers. And Salahud also observed by using zinc chloride, using precipitation method as well. And the calcination temperature at 400 degrees centigrade, and it was found that the particle size is about 74.5 nanometers. And if you look at the functional group, that's mostly for the metal oxide. The searching vibrations occur below 1,000 per centimeters, and particularly for zinc oxide, usually around 500 per centimeters. So here, if we look at the brown spectrum that belongs to zinc oxide microparticles, the zinc and oxygen bond searching vibration occur at 470, while for zinc oxide nanoparticle is rather elusive. That's about 465 per centimeters. Moreover, that the absorption peak for the zinc oxide nanoparticles is even sharper compared with the zinc oxide microparticle. This indicates a transformation from microparticle dimension to the nanoparticle dimension for the zinc oxide nanoparticles. Due to the, what we call it, safe size control by adding capping agent as well as the heat treatment at temperature of 400 degrees centigrade. In addition, we found here there's a nitrate stretching vibration here, which indicate that some of the nitrate are still in the product. Yeah. And also the OH vibration is quite large for the zinc oxide microparticle, that indicates that there is quite dominant still here beside the water. But for the zinc oxide nanoparticle, it's quite small as compared with the zinc oxide nanoparticle, that this is due to the absorption of water. In the term of the crystallinity, we also can see here from the diffraction XRD pattern for zinc oxide microparticles, the blue one here, it shows that, and as we compare with the standards or the reference coming from the GCPDS or Joint Committee for Broader Diffraction Standard, it indicates that this is the zinc hydroxide, zinc hydroxide containing nitrate, and is having a monoclinic structures. That's due to the low hydrothermal synthesis, as we know that we just put it in the oven for 105 degrees centigrade. On the other hand, for the zinc oxide nanoparticles, we can see that the patterns showing the crystal structures according to the GCPDS that belong to the hexagonal woodside structures. And this, even we can see that the peak is quite sharp here, which indicate that a high crystallinity of zinc oxide nanoparticles. And when we try to calculate by Scherer equation, we obtain the average crystalline size of zinc oxide nanoparticles about 74 nanometers. So in conclusion, that zinc oxide microparticles were obtained by neutralization of zinc nitrate and drying the precursor at 105 degrees centigrade, while zinc oxide nanoparticles were obtained after neutralization and adding the capping agent. It will heat it up to 100 degrees centigrade, producing zinc oxide nanoparticle. The SEM also shows that microparticles have a irregular shape, such as flakes. On the other hand, for the zinc oxide nanoparticle, it shows the spherical shape with the size of around 80 up to 100 nanometers due to the calcination process. The FDR also show that the broad absorbance band that related to the stretching vibration of zinc oxygen bond. The XRD confirm that the precursor of zinc oxide microparticle still exists there, even a small part only for the zinc oxide as compared with the zinc oxide nanoparticles having the pure woodside structures. And the crystalline size is about 74 nanometers. And I'd like to acknowledge to our colleagues in the department for providing facilities and also collaboration in financial collaboration research. And thank you for your attention.
Thank you, Mr. Haryadi, for the presentation. So the next presenter is Mr. Adit Adep. We get Moko because Mr. Emrizal Mahidin Tambo Esai we could not find in the room. Or is there any representative of Mr. Emrizal Mahidin? If not, so we just go to Mr. Adit Adep Wiatmoko. Okay, let's start.
Thank you very much. Before starting the presentation, I would like to thank the organizer for giving me an opportunity for the talk. Today, I would like to present part of our study. The title is Conversion of Furfuryl Alcohol into Oligomers of Reactivated Carbon-Supported Molybdenum Oxide Catalyst. By 2030, some study says that energy demand will increase almost 50% from today's level, driven by economic progress and population growth. Of course, to overcome this issue, people are trying to produce new and renewable energy, and lignocellulosic biomass as a sustainable energy source can be converted into the renewable energy through several primary routes. One of them is gasification to produce syngas, and then the other one is hydrolysis followed by fermentation to produce bioethanol or biobutanol, and the last one is pyrolysis to produce bio-oil, which can be upgraded into the hydrocarbon fuels. On the other hand, the hemicellulose in the biomass have been successfully converted into furfural. This furfural, after hydrogenation, will be converted into furfuryl alcohol, which is very important compound to produce jet fuel precursors through dehydration and condensation reaction. As we mentioned before, furfuryl alcohol can be converted to form dimeric and trimer compounds through dehydration and condensation reaction by releasing water in two different reactions. The dehydration depends on the acid and metal strength of the catalyst to determine the selectivity of the reaction. Among those catalysts, molybdenum oxide has been reported as an efficient catalyst to convert furfuryl alcohol into its oligomer. This molybdenum oxide has the oxidation number of 6+ and 5+, which is very active for dehydration reaction and condensation of furfuryl alcohol. However, the previous molybdenum oxide was used or utilized in the bulk form. So our study here trying to use the activated carbon as a support for supporting the molybdenum oxide for this reaction. So we select the activated carbon as a support since it has a very high surface area and also it has the very good acidic property which is very useful for the reaction. The loading of molybdenum oxide was done by simple impregnation at room temperature, and then after drying and calcination at 600 degrees Celsius for 2 hours, we obtained the catalyst. The synthesized catalyst was further used for the dehydration reaction at 100 degrees C for 2 and 4 hours. In addition to our synthesized molybdenum oxide on the activated carbon, we also prepare the bulk molybdenum oxide that we obtain by direct calcination of ammonium heptamolybdate at the same temperature for 2 hours. And this bulk molybdenum oxide showed orthorhombic crystal orientation. However, our synthesized catalyst, which is molybdenum oxide on activated carbon, showed a monoclinic crystal, which corresponded to molybdenum dioxide. This molybdenum dioxide is an intermediate product of molybdenum, of the conversion of molybdenum trioxide into molybdenum carbide. However, it is formed due to the insufficient temperature of carbon diffusion to dissolve the oxide phase of molybdenum dioxide to molybdenum carbide. From Raman spectroscopy analysis, we can see here that the bulk molybdenum oxide shows the several peaks with wave number correspondence for orthorhombic molybdenum oxide. However, this was not observed for molybdenum oxide supported on activated carbon. And then, as we expected before, the molybdenum on activated carbon, molybdenum oxide on activated carbon show much higher acidity compared to the bulk molybdenum oxide. Of course, this acidity comes from the acidity of the support itself, which is activated carbon, which contains functional groups that corresponds to the acidity of the material. And then, as we mentioned before, the bulk molybdenum oxide is kind of a non-porous material. As we can see here, the surface area is about very low, 1 meter square per gram, and it has no negligible micropore area and pore volume. However, our molybdenum oxide on activated carbon shows much higher surface area. It's about 100 times higher than the bulk molybdenum oxide. And we believe that this kind of property is very important for our reaction. As we can see here from SEM analysis, the molybdenum was well dispersed on the surface of our activated carbon. And it is not clear how big the size of molybdenum oxide on our activated carbon. From our EDS analysis, we can see here the amount of molybdenum is quite similar with the theoretical loading of the molybdenum, which is around 18%. And after the reaction, we measure the conversion of sulfuric alcohol. After normalization with the amount of molybdenum oxide, we can see here that the activity of our supported molybdenum oxide is much higher, about 5 times compared to the bulk molybdenum oxide. And how about the product distribution from sulfuric alcohol conversion of our catalyst? As we can see here, sulfuric alcohol can be converted into various compounds, and it is difficult to mention one by one of the compounds. So what we have done is we combine or we make it into 3 different groups. The group which contain only monomer, and then the group which contain dimer and trimer, and this is our target. And the last one, the group which contain unknown compound that we could not assign from our MS result. And from this result, we can see here that at 2-hour and 4-hour reaction, the product distribution for dimer and trimer compound for both catalysts is quite similar, which means that there is no effect for the selectivity of the catalyst after loading on the activated carbon. And the last one, we have shown that molybdenum oxide on activated carbon was an efficient catalyst for furfuryl alcohol conversion into oligomers, which is specifically dimer and trimer. And this result, we believe that is important. We believe that this result is very important to further improve the catalyst performance for improving the selectivity towards a dimer and trimer compound, which are very useful for jet fuel precursors. I think that's all from me. Thank you very much for your kind attention.
Thank you very much, Mr. Ade. So we will continue to the next presenter, Miss Yeni Meliana, who is represented Mr. Ian Irawan, and Miss Yeni Meliana will have a live talk. So please share your presentation and start your presentation. Time is yours.
Bu Kiki, let me share my presentation right now. I hope everybody can see the screen. Okay, thank you. Thank you for the committee for this opportunity for our team to present about our work. The lead of this project is Ian Irawan. I'm the one of the co-author for this work. We are come from the Research Center for Chemistry, Indonesian Institute of Sciences, or now we known as BRIN. The topic is about synthesis and characterization of non-ionic surfactant based on stearic acid through propoxylation reaction. So this one for the introduction. We know surfactant are used as active surface, which can reduce the surface pressure of the liquid. There are 4 types of surfactant: non-ionic surfactant, anionic surfactant, cationic surfactant, also for the amphoteric surfactant. Surfactant are compounds that can be used to reduce surface tension because they have hydrophilic. This is the hydrophilic group and the hydrophobic groups, like this one and this one. So they can unite or mix between water and oil with well because they have this kind of hydrophilic and hydrophobic group. This is from previous research. Al-Sabak has synthesized the surfactant with the oleic acid as raw material. In this work, the Al-Sabak used 0.3% sodium metal catalyst and using various of polyethylene oxide and polypropylene oxide with varying molecular weights. The produce such product from this polymeric surfactant, we can see like this structure, this one and this one, with different of the head of the group for the hydrophilic group for the surfactant. This is also from previous research, synthesis of non-ionic surfactant from glycerol monooleate with ethylene oxide using 1% potassium alcohol catalyst to produce ethoxylate glycerol monooleate, which is this surfactant, polymeric surfactant, is also soluble in water and has the potential to be used as a surfactant for the cleaning and cosmetic products. So what what we want to solve in this study, this is include what is the optimal ratio of stearic and polypropylene oxide in surfactant synthesis with a propoxylation reaction. And the second one, how is the character of this product of polymeric surfactant? This is for hypothesis and the goal. Hypothesis is first, surfactant with optimal polymerization is produced from the ratio of stearic acid with the smallest propylene oxide will be included is 1:2. And then the resulting non-ionic surfactant has the ability to form emulsion. They are stable and more likely to be hydrophobic. So the goal, the aim of this work, to get the optimal polymerization of stearic acid with propylene oxide, and then to produce surfactant with good emulsion stability and tends to be hydrophobic. This is the benefit from this polymeric surfactant products to provide, this is benefit from our work to provide knowledge that non-ionic surfactant with good emulsion stability and to be hydrophobic are produced by propoxylation reaction from stearic acid raw material, which is derivative of palm oil. This is the methods. And then I will continue for the result and discussion. Stearic acid propoxylation surfactant can be synthesis occurs through of 3 steps. So first step is initiation, continue with the propagation, and the end of step is with the termination of reaction. And this is for identification of propoxylate stearic acid. So this is the value of acid value and ester value from the propoxylate stearic acid. So we can see here the decrease of stearic acid to this stearic acid propoxylation will be occurred due to the elongation of the active carbonyl chain of stearic acid to form non-ionic surfactant. So the decrease in the acid value is also caused by the use of the potassium alcohol in the reaction. And the increase in the ester value will be occur because the asteric acid chain is elongated by the polyethylene oxide to form a non-ionic surfactant which has an ester group in the structure. So the more propylene oxide is added, more propylene oxide in the reaction, the more ester group will be produced in the stearic acid propoxylation structure. This is the molecular weight from the propoxylate stearic acid. We can see here stearic acid is fatty acid that has solid form at the room temperature. We can see from this figure. So the more polyethylene oxide, when we add this more, the softer solid are produced. This is because the stearic acid solid in the product have already reacted with the propylene oxide, so that the density will be continue to decrease. In this stearic acid propoxylation, it appears the maximum propylene oxide molecule is 4 molecules. So with the long chain is 4 molecules for the propylene oxide. This happened because the ratio of stearic acid then the concentration of catalysis are fixed. According to Laxmono in 2008, in the use of catalysis, which is in the range 1 till 5% catalysis, will be more polymerization occur in the reaction with when it 5% of catalysis. This is result of the functional group. The wavelength value from the FTIR. So it shows the functional group from this structure molecule, stearic acid propoxylation. And this also characterization from the NMR, we can see in this yellow part, this is to indicate this polymeric surfactant stearic acid propoxylation already occur in this reaction in this work. This characterization of propoxylate stearic acid for the physical characterization. This is for the particle size and polydispersion index of propoxylation stearic acid. We can see here average for the size of the emulsion droplet in this polymeric surfactant is occur between 150 nanometer to 450 nanometer. So longer chain of the propylene oxide, the size of the molecule will be decreased. This is the data for the zeta potential of the propoxylate stearic acid. We can see here, it can be seen when the stearic acid propoxylation with the ratio 1:4 is very high zeta potential that can make a very stable emulsion. The result is minus 46.1 microvolt, while the other polymeric surfactant sample have a high zeta potential value that can make a stable emulsion. This is the range for the stable emulsion. When is more than 30 is indicate this polymeric surfactant is very stable. This is the value for the hydrophilic and lipophilic balance. We can see the data for the hydrophilic and lipophilic balance here. The SLB value will increase with increasing molecular weight and the number of polyethylene oxide moles that added to the surfactant structure. So for the conclusion, the polymerization reaction of stearic acid propoxylation formation has occurred, evidenced by the result of determination of acid value and ester value, and also for the data from the FTIR and the 13 carbon of NMR instrumentation. The most optimal polymerization reaction was obtained when the ratio from the stearic acid with the propylene oxide is 1:4, with a molecular weight is 570 gram per mole, and there is 4 molecule propylene oxide that inserted to this polymeric surfactant. Stearic acid propoxylation with the particle size characteristic that meet the standard for the use on the EOR, enhanced oil recovery, is this for the first formula 1:4, 1:6, 1:8, and 1:10, with particle size in the range is between 140 till 160 nanometer. When the stearic acid propoxylation ratio is 1:10, has the best distribution for the particle and from the stable emulsion, with the polydispersion index value is 0.336, and the potential zeta value is minus 27 microvolt, and the millivolt, and the most hydrophobic with the SLB value of 7.47. Thank you. I will stop the share. I give it back to Bu Kiki. Thank you.
Thank you very much for all the presenters. Very interesting presentation. So now is the question and answer, the discussion section. We already have many questions in the chat box. So first is for Dr. Haryadi from Dr. Saifur Rahman from Research Center for Chemistry. So can you explain the relationship between the particle size of zinc oxide and the stretching bond of zinc O? Please.
Okay, thank you for the question. Basically, there's no relationship directly between particle size and the stretching bond for the metal and oxygen, for instance. But basically, the relation is directly with the composition, actually. So the composition of metal and the oxygen that having the stretching bond. So in this case, maybe if we look at the results, of course, we compare between microparticles of zinc oxide and comparing with the zinc oxide nanoparticles. In zinc oxide nanoparticles having a high stretching vibration for zinc and oxygen, while if we compare with the microparticle, it's only tiny. If you look at back in the what do you call it, in the infrared spectra, if I allow to present the screen first for the moderator, just to clarify. May I? Can you see here? Yeah, if you look at, okay, if you look at this one, so the blue one is just a zinc, this is basically zinc hydroxide still. It's only a small quantity of the composition of zinc oxide microparticles, actually, as compared with the zinc oxide nanoparticle here. And this confirmed by, which means that this is for the zinc oxygen stretching vibration in microparticle, and this one in the zinc oxide nanoparticle. And if you look at the XRD here, it's quite clear that this is the one, the zinc oxide nanoparticle for the red one, yeah, and the hexagonal side is quite clear here, and crystallinity is also quite high. Only small amount of zinc oxide here that belongs to zinc oxide microparticles. So again, there's no direct relationship with the particle size, but only the composition. I think that's my answer for Dr. Saifur Rahman. Thank you.
Thank you, Pak Haryadi, for your explanation.
Okay, no problem.
Okay, thank you, Dr. Haryadi. Okay, for the second question, also from Dr. Saifur Rahman to Dr. Adep. Can you explain the source of acidity in activated carbon? What kind of acidity, brown state or Lewis? Although Mr. Adep have already answered it in the chat box, maybe other participants want to hear it directly from Dr. Adep. Okay, please.
Thank you, Mbak Kiki. Thank you for the question. As I wrote on the chat room, that we actually utilize the commercial activated carbon from Aldrich, and unfortunately, we don't have any tools to characterize the carbon. Actually, acidity from carbon, as I know, it comes from the functional group of the carbon. So if we can clearly observe what kind of functional group, so we can decide what type of acidity on the surface. As far as I know, the method to characterize the carbon is using it's kind of TBD connected with the MS. So when the carbon is heated at high temperature, the functional group will be released, and then it can be detected by the MS detector from the instrument. And then we can see what type of functional group, and then we can decide what type of acidity. On the other way, to know the type of acidity, we can use the pyridine IR instrument, and unfortunately, we don't have it yet at our research center. So hopefully, next time our management will provide it for supporting the research of chemistry and catalysis, I think that would be very good for us. So by using the pyridine IR instrument, we can clearly see in the peak of Ronstadt and Lewis from our measurement. So I'm sorry I could not answer what type of acidity that we have in our activated carbon now. I hope that's answer your question, Dr. Saifur Ahmed.
Thank you, Pak Ade, for the explanation.
Okay, yes, thank you for the answer, Mr. Adep. So yes, actually maybe using the simple characterization by FTIR, so we can also determine, but in a rough, the Lewis or acid. And
thank you very much, Dr.
Yeah.
The additional answer.
The third question is for Dr. Yeni from Pak Egy Agustian. Okay, what is the benefit when we synthesize this polymeric surfactant compared to other surfactant? Okay, please.
Okay, thank you for the question. Actually, why people want to produce this polymeric surfactant? What is the benefit? This polymeric surfactant will be represent a very attractive alternative to get the more stable of surfactant, because for the polymeric surfactant they can provide simultaneous increase in water viscosity and also decrease in interfacial tension. So both this beneficial for the efficiency of the process. And for the polymeric surfactant is usually specially designed to produce excellent dispersion agent for the suspension, and also designed for the good emulsifier for the emulsion. So that's the benefit why we want to produce the polymeric surfactant. I hope it can answer the question. Thank you.
Is that okay with the answer, Mr. Egy, or you want to ask more deeply about the answer?
Thank you for your answer, Dr. Eni.
Okay, other participant, if you have more question, please just drop it in the chat box, or you can ask directly.
Yeah. I have one question to the second presenter, Pak Adep. Maybe any consideration regarding using activated carbon instead of like zeolite or other supporting material for in this case? Is there any consideration why you use activated carbon instead of like zeolite, either natural or synthesis, or even other supporting materials?
Okay. Thank you very much for the question. Honestly, I didn't think to use other support yet, but the important thing for the dehydration and concentration is the two things. The first one is the acidity of the catalyst, which determine the product selectivity. So at that time, we prepare 3 different kind of support for this this reaction. So the first one, we choose the alumina, and the second one is magnesia, and the third one is activated carbon. And the interesting result that we obtain is on the carbon. And then we try to find the catalytic descriptor for this reaction. And unfortunately, the work is not complete yet. So if we try to find another support, like for example zeolite, I think it is also interesting work to do in the future. Especially the zeolite is much better in terms of the regeneration after the reaction. If we have a carbon, it will be tricky and slightly difficult to regenerate the catalyst after the reaction, since it will be burned if we temperature to clean the surface of the catalyst. So I think that would be very good to do in the future. Thank you.
The thing is that when Dr. Saifur Rahman asking about the acidity, for instance, right? The zeolite, actually zeolite has silica and alumina, and we can adjust the ratio, and then that's gonna be change the acidity as well. That's why I'm just following the Dr. Saifur Rahman mentioned that regarding the acidity of the support in this case, yeah. So instead of the catalyst itself, so then the ratio of the silica and alumina in zeolite really distinguished for the acidity, and that's going to be a benefit for the catalytic activity as well, I think.
Yeah. Thank you very much, Dr. Haryadi. It would be very good to do in the future, I think. Yeah.
And for Dr. Yeni, I have a question as well?
Okay, you can ask a lot of questions actually. If I can answer those.
Yeah, I mean, what is the goal once you cut the surfactants? Then what's the main objective for application, for instance?
Oh, for this polymeric surfactant, stearic acid propoxylation, this will be applied to enhance oil recovery. So we know oil from the fossil resources in Indonesia, a lot of like oil well that only left and very difficult to get the oil. So using this polymeric surfactant will be make bending with this polymeric surfactant, and will be make it easier to get more oil that like hide in the small pore in the old
rocks.
Yeah, in the rocks in the old well of the fossil oil.
Okay. But have you ever tried for that one, or hasn't been applied for this?
Yeah, we already applied another polymeric surfactant. So this one we try to synthesize the other one. All this polymeric surfactant is derived from the palm oil derivation. So we try to use our a lot of source of palm oil. We derived, including became this polymeric surfactant.
Okay, thank you.
Thank you, Dr. Haryadi.
Okay, thank you. And we also have a question to Mr. Adep from Dr. Nino Rinaldi. You said that the reaction needs acid source, which is from the catalyst. So how do you use molybdenum as the active metal? So far, I have read that using nickel or copper are as the active metals could source and increase the acidity. What is your opinion about this?
Thank you very much for the question. Unfortunately, I don't have any idea for the question, but the thing that why people doing with molybdenum oxide, because this molybdenum oxide has two different valency. I could not find the word in English. I'm sorry. So it has a 5+ and 6+ during the reaction. So I think it would be better if I share the slide that contains that one. It will be here. So why this molybdenum oxide is active for the reaction, since it has these two different valence, 5+ and 6+, and both of them are active during the reaction. So this furfuryl alcohol is connected with this oxygen bond on the edge of this structure of molybdenum. So that's why this molybdenum oxide is active during the reaction. And our idea is only to increase the surface of active site. So if we use a bulk molybdenum oxide, it will be only this small surface area of molybdenum oxide. But if we spread it on the surface of activated carbon, which has a very high surface area, we hope that the activities increase much more higher. That is our idea. And of course, and the support itself, the activated carbon has some acidity, which also improves for the dehydration reaction. And I don't know if this nickel or copper will active during the reaction or not. I need to look into the literature and some reference, and I could not answer the question. I'm really sorry, Dr. Nino.
So continuing your discussion, so you said that actually you want to have a very high surface area, but by supporting the molybdenum as the SEM result, you know that the size of the molybdenum is quite big. And also the surface area decreasing very much. So is that your future target? Do you have any work with that to decrease the particle size of the molybdenum? Maybe just like Dr. Haryadi, to make it in a nanoparticle or something. Do you have any strategy how to overcome that?
Thank you, Dr. Sembiring. Actually, we don't know the size of molybdenum oxide on our surface of activated carbon. The size that you might see before is the size of the carbon itself or the size of bulk molybdenum trioxide. I think I can show again that data, I think. SEM image would be this slide, right? So as you can see here, this left part is our bulk molybdenum oxide, which we obtain from the calcination of ammonium heptamolybdate directly. And this is very big size of big particle size of molybdenum oxide. And then we compare to our molybdenum on activated carbon. And this is the size of activated carbon that we have. And the molybdenum, it's this tiny green dot. So we cannot clearly see how big the size of molybdenum on the surface of carbon. And we believe that the dispersion of the molybdenum on the carbon is very good since it covers all the part of the carbon. So I think in SEM, to clearly see in the size of the molybdenum oxide.
I see. Thank you for the explanation. Okay, so actually we still have a lot of time. So I want to ask one question to Dr. Haryadi. I'm sorry for the title that has been changed because my data, the previous one. So is this is your research will be applied for the battery actually?
No. We just use the what we call the metal source as a zinc. What we call zinc resources. Yeah. We made actually zinc oxide nanoparticle and zinc oxide microparticle, and then we apply as an additive actually, combining with the epoxy resin to reduce the corrosion as a corrosion inhibitor. And we found that it's quite significant difference because when we use the microparticles and then we replace with the nanoparticles, then the inhibition rate is more than 100 times greater for the nanoparticles. That's why. But I didn't put in this presentation, but we have done that one when we apply it in the carbon steel as well in the aluminum metal. Sorry.
Oh.
So we have applied for that one, and then it's quite significant improvement while we're using the different size of particles, micro to nano, and then the inhibition corrosion reduced 100 times less than for that.
So the application is very promising in the future.
That's why we're using only the waste anyway to apply for this one.
Yeah, that is the point also to utilize the waste. Okay, thank you very much for all the presenter in the session 1. I hope you all will still stay in this room to hear the next presenter. Okay, the next is Mr. Egy Agustian. He will have a talk, the effect of ultrasonic treatment on titanium pillared bentonite synthesis. Okay, please, Mr. Asa. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Madras, for the today I want to share about my research with the title, the effect of ultrasonic treatment on titanium pillared bentonite synthesis. This is outline presentation. We know that the bentonite is the natural resource in Indonesia, about 7 million in the production in the 2019. Indonesia clay is majority are calcium and natural bentonite. Calcium bentonite is consistently increased every year due to the industry of palm oil required for absorbance. Moronite is one the majorly component in bentonite. Moronite has the micro porosity and walls ion exchange capacity. Bentonite can be modified or pillar clay is more benefits. Due to widely used as a low-cost catalyst, according to the reference, pillar bentonite as a catalyst is 300 times soluble compared to natural bentonite. This is established technology for preparation pillar bentonite. We use the soil gel methods, hydrothermal process, and the mechanical stirring methods. Those methods have the drawbacks. They are longer preparation and time process, high temperature, and difficult to handling for preparation. However, the method needs longer preparation and time to be pillars. Therefore, to get the faster and more effective method to preparation of pillar clay, one alternative technology is the ultrasonic with the high power output was used. State-of-the-art ultrasonic. For the sonic chemistry, we use the low frequency 20 kHz and the high intensity more the 50 watts output powers. Okay, we can decide we will be describe what the mechanism for PLC by ultrasonic. Systemic inflow the use wave with the frequency 60 kHz until 100 MHz. While human hearing is 20 kHz to 60 kHz. In the right picture, you can see when the liquid is irradiated by the strong ultrasonic wave, and then large quantity of tiny gas bubble appear and collapse violence, and then this phenomena called the cavitations, and then the tiny bubble repeatedly expands and grow the bubbles and the contact according to the pressure and ultrasonic wave. The speed bubble collapse sometimes increase up, and the strong hydraulics bubble will be penetrates of metal oxide nanoparticle into the interlace spacing in the layer structure of clay. This is the comparison about the PLC by ultrasonic. You can see number 4. Use the method ultrasonic horns 20 kilohertz, 500 watts with the condition 40 minutes and temperature ambience. You can see the catalysis, basal spacing, surface area makeover for volume increase significantly. And then this slide describe the comparison sonication by versus conventional method. You can see the time finalization. Conventional method need 24 hours to be pillars, but the ultrasonic need 20 to 30 minutes to be pillar at the ambient temperatures. For all the state of the arts, we choose the objective of study, effect of time sonication on synthesis of PI pillars bentonite by ultrasonication technique, and compare with the conventional methods. The characterization of PI PLC was performed by XLI, chemical absorption, and nitrogen gas absorption technique or BT. This use titanium isoproposite has a strong resist and bronzite acids, lower pore size, its stable properties and more acidity, and also surface area. This is a methodology for preparation of pillar bentonite. We use the horn ultrasonic Sonica 1375 20 hours and maximal output power 1030 75 watts. This is the transducer, and this is the horns, titanium alloys, and the generators to the parameter we use. So go to the methodology. Titanium isoproposite and chloride acid hydrolysis with the agitation 3 hours at room temperature, and with the Volkswagen's the isolation, and the mixing together with the suspension bentonites with the 30 minutes, and for that sonication with the various 10, 30, 50 minutes for time sonicated, and the separation use and refuse, washing, dry open, and the get the catalyst, the IPLC. Okay, result education, you can see the table, surface area, pore volume, acidity, and the content titaniums, TI, SIRs. You can see the presence of titanium increase the surface area and acidity. Okay, all the TIPLC display the raw surface area and acidity than the calcium bentonates. Okay, you see clearly the presence of titanium contribute to the increase the surface area, while at the same time lowers of the ratio ELs, aluminiums to SIs. Okay. The surface area, pore volume, surface acidity, and titanium content were found to be the highest in the TiPLC 50, which is also higher than TiPLC conventional techniques. You can see in the graph surface area, pore volume, and time sonication. This is a linear curve with increasing the time sonication will be increase the surface area and pore volume. Surface area, pore volume increase, time sonication will be increased. So if we compare TiPLC 50 versus TiPLC conventional, we need time 50 minutes, but the conventional need 20 hours. Both the surface area VAT, TiPLC 50 have a large surface area compared to conventional TiPLC, and also the acidity, the total acidity of the TiPLC will more dense, high compared to conventional TiPLC. How about the absorption spectrum curves for synthesis of TiPLC with the various time sonication? The left picture, fluorescent volume absorbance with the relative pressure. The absorption desorption slope can be classified as a S3 type in the UPEC classification. You can see the slope of hysteresis slope, the steepest for samples, the longest durations, right? This is a TiPLC 50 is the sample also contain the highest example calcium with the titanium as evident from the elemental analysis. So, in the right picture, you can see the TiPLC 10 and TiPLC 50 is mesopore size distribution as around 5 nanometer, almost to near the micropore size. The last conclusion, the ultrasonic technique has been successfully used to synthesize TiPLC. TiPLC 50 preparation ultrasonic produce sample with the best characterization for 5 minutes, much shorter time than the conventional process of the polarization. Okay, after 15 minutes ultrasonication, the TiPLC sample contains 20.8 they having a high surface area, high pore volume, and high surface acidity. The surface area pore volume on the TiPLC increase with the increasing ultrasonication time. The cavitation bubble action during ultrasonication induces micro and mesopority in the PLC and TiPLC. And the last, the further research will be test performance of polar bentonite as a catalyst to esterification of waste cooking oil in supercritic CO2. I want to say about thanks for the University of Indonesia for the grant doctoral research and the PT for the PN's National Project Program and the scholarship by research LIPI. Thank you very much.
Thank you, Mr. Eki Agustian. And then we will hear the next presenter. Ms. Christina Wahyu Kartikowati. She will have a talk, preparation of TiO2 coat glass and their application for photodecomposed organic dye. Okay, please.
Good afternoon, everyone. My name is Christina Wahyu Kartikowati. Today, I would like to present my research entitled Preparation of TiO2 coated glass and their application for photodecomposed organic dye. Photocatalytic method is one of advanced oxidation process which can be defined as acceleration of reaction in the presence of photon and catalyst. This photocatalytic technology has been known as one of the eco-friendly methods to decompose organic pollutants. It can also be applied in wide applications such as water treatment, air treatment, and water splitting. TiO2 is the promising photocatalyst material that can be activated under UV light irradiation. However, along with the advantages, the TiO2 also has disadvantages. The specific surface area is one of the ways to enhance the photocatalytic activity. However, the post-handling of the TiO2 nanoparticles being another homework. Therefore, we try to prepare the TiO2 coated glass and their photocatalytic activity to decompose organic dye. First is experimental method. There is several steps. First one is preparation of the glass. All the glasses was done support by washing with acetone, then dipped in the H2SO4 and then dipped in KOH for 3 hours. The TiO2 salt was prepared using two solutions. First solution is TiO2 annotation with acetone and its aqueous, and the second solution is Triton X and PEG, polyethylene glycol. And then these two solution mixture to make a final solution. After the solution was prepared, then the salt TiO2 dip the glasses dip on TiO2 salt and TiO2 solution sprayed on the glass. After that, dried in room temperature and then dried up in oven for overnight and then calcinated for 2 hours. After we get the glass coat TiO2, then we analyze the activity, the photocatalytic activity using rhodamin B 4 ppm, and this is the step to analysis the photocatalytic activity using UV irradiation for 120 minutes and then centrifuge for 10 minutes and then using UVV spectrophotometer. This is the result of our experiment. First, this is the XRD pattern of prepared TiO2 annotation nanoparticles. The result showed that the XRD peak referred to ICDD number 04,014,8515, indicating that TiO2 annotation phase with a crystal size of 34.39 nanometer. And the morphology of the TiO2 nanoparticles were agglomerate with heterogeneous size diameter. The particle size was in the range of 60 to 200 nanometers. This is the result of dip coating and spray coating. For the A and D is 1 time, B and A is 3 times, and C and F is 6 times. For the dip coating, the glass plate surface was covered by TiO2 almost perfectly. And for the one-time coating step, TiO2 adhered on the glass surface with a line texture. And for spray coating, heterogeneous the TiO2 have a heterogeneous covered the glass surface. And for the one-time spray step, the TiO2 adhered on the glass surface with a dotted texture. And this become thicker when the coating was added, but deep coating and spray coating processes were successful in adhering to TiO2 on the glass plate. And the effect of and then this is for comparison, we also do for a marble's surface. And the result is salt TiO2 adheres to the glass plate easier than the marble surface, and TiO2 on the marble surface was easily washed off. Therefore, the glass surface is better. This is the summarized mesh of the prepared TiO2 coat. The results show that mesh of the TiO2 on the glass plate by deep coating was lighter than spray coating, showing that the spray coating could produce a more effective coating process. And the change of TiO2 mesh was due to the PEG evaporated and the faded TiO2. The effect of various temperature of the post-annealing process is studied, and the results is this picture. It showed that at the lower annealing temperature, PEG was not evaporated completely, especially at 160 Celsius. 100 PEG completely remained on the layer, and 550 derajat Celsius was the ideal post-annealing temperature. This is the result of photodegradation of 4 ppm rhodamin B over TiO2 coated. The first one is marbles, and the second one is on the glass. The efficiency increased by increasing the coating step by using 30 grains of coated marbles, and the optimum condition was achieved when the coating process was 6 times. And for the glass plate, TiO2 coated glass plate showed a lower efficiency. Under a small amount of TiO2 immobilized TiO2 on the glass plate support show a better efficiency than marbles. This is so that in the glass plate is better than in the marbles plate. We also study the effect of annealing temperature on the photodegradation of rhodamin B over TiO2 coated glass plate, and the results show that the highest annealing temperatures resulted in the highest photodegradation, and the surface morphology possibly influence the decreasing of photodegradation. And the consistency of immobilized TiO2, the repeatability of photodegradation have been studied, and this is the result. It showed that photocatalytic activity of immobilized TiO2 showed an insignificant decrease due to the release of TiO2 during the washing process. Here it can be concluded that immobilized TiO2 on the glass support simplifies the separation process after photocatalysis and could maintain the catalysis capability for repeated use. The last one is the summary. First one, immobilized TiO2 on the glass support has been successfully prepared by the dip and spray coating method. Dip coating was easy to be applied in the small scale and marbles glass type. However, spray coating is possible to be applied for the coating process on a larger scale, especially for glass plate types. The photocatalytic activity showed that the coating process did not influence the activity of the catalyst. And the last one is 4 ppm of rhodamin B succeed in decomposing up to 100%. And it's the end of my presentation, and thank you.
Okay, thank you very much. So we have the next presentation, Mr. Emrizal Mahidin Tambo Esai, with the title is Utilization of Solid Waste Pulp, Green Liquor Tracks and Slacker Grits from PT Indah Kiat Paper Factory for brick making. Okay, please, Mr. Asa, the video. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the chance to me to explain about my research. Title is Utilization of Solid Waste Pulp, Green Liquor Dregs and Slacker Grits from PT Indah Kiat Pulp Paper Factory for brick making. In the 7th International Symposium on Applied Chemistry 2021. This research used the waste of pulp solid waste, green liquor dregs, and slacker grit from PT Indah Kiat's pulp and paper. The problem is first to analyzing the chemical composition of solid waste, the dregs and grits that can be used as a mixture in making bricks. Second, to analyzing the effect of weight ratio, cement, sand, and solid waste pulp from green liquor dregs, slacker grits, and water absorption on the compressive strength of the resulting bricks. That's to analyzing the correlation of the effect of the addition of solid waste on the quality of the bricks produced. This research purpose to analyzing the chemical composition of PT Indah Kiat pulp and paper solid waste from dregs and grits that can be used as a mixture in making bricks. Second, analyzing the effect of the weight ratio of cement, sand, and solid waste pulp from green liquor dregs and slacker grits, and water absorption on the quality of the resulting bricks. This research conducts for 6 months at the Material Science Laboratory, research laboratory in organic material, geochemistry, and mineralogy in organic chemistry, Department of Chemistry, Faculty of Mathematics and Natural Science, Riau University, and Faculty of Technique, Riau University, Pekanbaru, Sumatera, Indonesia. This is the research methods used to furnish an analytical balance, often shift fluorescence, scanning electron microscopy, universal testing machine, and analytical glassware. Material used like solid waste pulp, drag and grits, cement, water, sand, The procedure research first is to chemical content analysis, to knowing the chemical content of calcium oxide, silica oxide, magnesium oxide, aluminum oxide, ferro oxide in the sample, using the instrument XRF. Second is sample preparation, preparation of cement, aggregate, sand, pulp, solid waste, and water, and make the brick. Water absorption test, using like this, and then compressive strength test. Prepare the compressive strength test equipment to be used, installing the press to crush the test sample, put the test sample just under the pressure tool, tuning the level to the right while looking at the needle, determining the value of X until the test sample breaks. Then record the value of X sound after the test sample breaks to determine the amount of force that's required. This is the result of chemical content from analysis with XRF. This result show that content of silica oxide, aluminum oxide, calcium oxide, ferro oxide is the main component in the bricks, in the waste solid. This result is very important to know, because the component make bricks. This is the scanning electron microscopy, water absorption, compressive strength test. My result is the result or the conclusion is the properties and characteristics of solid waste pulp, drag and grits, or petinakiat is very good for making bricks, because it contains chemical component like calcium oxide, for adhesive, silicon oxide, and aluminum oxide as a filler, and the presence of ferro oxide for hardening. The value of a compressive strength produced from its waste, especially waste grit, is very good for use in making brick. This is because the chemical composition of this waste contain a lot of silica oxide, aluminum oxide, calcium oxide, compared to the direct waste, like the table in the result. Each of which has a function as a filler in a mixture bricks, accelerate hardening, and help the process of gluing, bonding in the manufacture of bricks. Accelerates hardening and help the process of gluing, bonding in manufacturing of bricks. In brick formation of the calcium oxide content is very important, because it functions as adhesive, and from its characterization, so that's calcium oxide content is 58% in bricks and 59.7% in grits. From the research method carried out by mixing direct and slacker grit with other material, 2:10 and 1. The best result we obtain at the maximum value of compressive strength of quality 1 brick is 7 MPa. DSNI only 3,5 MPa. This is my presentation. I want to say thank you very much. Alhamdulillah and terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for all the presenters, the very interesting presentation. So we continue to the discussion. We already have a question from Dr. Saifur Rahman to Mr. Egi Agustian. So what will happen? Sorry. Okay. Since you are using natural bentonite, have the bentonite use been standardized? Or how do you standardize the bentonite use, since their characteristic might be affected by where the bentonite was sourced? I'm sorry. Please, Mr. Egi.
Okay. Thank you very much to moderator. I know we use the bentonite for partition city from the local market, and then I cannot the specifics for the local markets, but we use our lab to analyze the raw material or the bentonite from Pakistan. So we characterize the bentonites by the XRF, FVR, BAT, and TPD, because I know the raw material have the main compound we call the monmurylonides. Monmurylonide is one of the compound we will be cation exchange with to the exchange with our metal, in the case titanium. So, but our team used the bentonite from the Sigma Madrid, and the same works by the titanium also. So we can compare the characteristic the bentonite the source from the Sigma Madrid and the local market. Okay, thank you very much.
Okay, thank you, Mr. Egi. I hope it can answer what Mr. Saifur Rahman asked. Okay, the next question is also for Pak Egi from Miss Yeni. Thank you for the interesting presentation. I have two questions. First, what will happen to the product when we continue the sonification more than 15 minutes or until 5 hours, for example? And the second question is, which one will give more effect to this catalyst, the time or the power of sonification process? Okay, please.
Okay, thank you very much. We try to answer. It's very difficult to answer. So, you know, the ultrasonic have the function in wave. Wave use the tiny bubble and the grow until he reaches bubble, and then one moment he destroy the bubble and they collapse, and then the bubble will be penetrate the titanium to the layer clay. If we more than 15 minutes, I think we must one pares for the times. We can know the optimum times. I think we have 1 or 2 points for the various waktu time sonication. But if we use the very strong intensity, the ultrasonic, the metal oxide to bentonite for cation action without inhibiting the surface. So that intensity of bubble cavitation with the high energy and the structure can hold it. This means the layer not longer hold energy from shock wave and collapse the layer dispersion. So the clay or the bentonite will be collapse, and titanium or another metal will be dispersed in the solution. If we use the powers ultrasonic or the time sonication until 5 hours and so on. In second question, what the time or the power sonication? Is it very interesting for the research and sonication? We have a data from the power sonication from the jet air zirconium PLC. This is increase the output power, but the surface area decrease. So we must test another analysis. We use just test the XRI and surface area to BAT, but we can't not the characterize with the XRD. XRD, I know XRD must be the low angle. We use the basal spacing. If the basal spacing shifting to left, is can be successful to the PLC for the bentonite. That's all for moderator to answer.
Yes. Thank you very much. Okay, Mr. Nino, please have your question.
As I also demand in the Mr. Egi study. So yeah, it's just like Mr. Egi said that until now we still study what kind of really effect between time or power if we use sonication in preparation of pillar clay, because in this case we have already found that more we use high power, is become the bentonite layer is become collapsed. But if we use low power and then we use long time, is also increase the properties of the bentonite layer. So we still find we still deep looking for what exactly the effect, but the main idea is why we use the sonication, because we want to save the time for the preparation time. At least we can more effectively in order to prepare the bentonite pillar. So usually we prepare the pillar bentonite for almost 24 hours or 1 day to get the reaction between the exchange reaction between the pillar, between the ionic in the layer, between the layer bentonite and the pillar we want to exchange. I think if we already find the question, we will the answer the question soon. Thank you.
Thank you, Dr. Lino.
Okay, thank you for the additional information. So actually, this now is under studying to get the final, what is the more important, which affect the process. Okay, yes. Then we continue to the next question to Ibu Christina Wahyu from Mr. Saifur Rahman. Can you explain as to why the rhodium B start to decrease after 60 minutes for the titanium oxide coat glass slide? What happened before that? Okay, please.
Excuse me, Miss Kiki.
Okay.
Okay. My name is Osi. I would like to answer the question. I'm sorry because Miss Christina has a bad signal, so she cannot hear what we discuss.
I see.
Okay, thank you very much for the question. I think is there still change degradation under 60 minutes, but yes, of course, it's not significantly compared to after 60 minutes. We think that maybe it was due to the dye not completely absorbed on the glass surface. As we know that the advantages of nanoparticle catalysis is the dye and the catalyst is easy to absorb on the particle surface. So it is to react with the photon. That's why then immobilize photocatalyst, the absorption of diorganic on the catalytic surface. For this case, glass. Thank you.
Okay, thank you for the answer. I hope it will answer Mr. Saifur Rahman. Okay, the next question is for Pak M. Rizal from Miss Yeni Meliana. Is this brick product is safe, for example, for human or for environment? Because it comes from the waste, the paper waste. So is it safe, or we can use that? Maybe we can use that waste easily. Okay, please, Pak M. Rizal.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the question. As we know, in my research, make bricks from the solid waste, slacker grit, and brick. This brick can be used for making building, street, but not known about the safety to health. So I recommendation to the next research for the health effects research. That's my answer. Thank you.
Okay, thank you, Pak M. Rizal. However, is it how the performance compared to the commercial bricks? Is it similar or something?
In my research, this brick better than commercial brick. We can see it from the MPa. The commercial bricks MPa is only between 3 until 4. But in this brick from solid waste can make brick MPa, it goes around 7 MPa. It's mean better hardness than the commercial brick. That's my answer. Thank you.
Okay, thank you very much. So actually it is perspective if we can also fulfill the safety products. Okay, thank you, Pak M. Rizal. Then we go to the next question from Mr. Haryadi to Ibu Osi maybe. The thickness of titanium oxide coat on the glass will greatly influence to the photocatalytic performance of dye molecules. Any consideration for this rather than measure the weight of TiO2 adhere the surface? And okay.
Okay, thank you very much for the question. Yes, of course, is there a correlation between the thickness of TiO2 and the photocatalytic activity? For example, for the glass plate, one-time coating process and three-time coating process has different efficiency significantly. However, when we increase until to 6 times, from 3 to 6 times, the photocatalytic activity not really significantly increased. So we conclude that, of course, is there optimum thickness from titanium dioxide. However, from this case, we didn't measure the thickness, so we didn't the measure correlation between the thickness of the TiO2 and the weight of the TiO2.
Okay, thank you for the answer. And how about the application of the spray and dip coating? If we apply the spray or dip coating, is there any consideration? I mean, until how big the material to be coated is effective for spray, or which one is for coat? Is there any specialization?
I think that spray coating is much better. It's more effective compared to dip coating, especially for a big scale, because spray coating, like we paint the wall or car, compared to dip coating. But yeah, unfortunately, from this case, the dip coating performer is much better than spray coating. So we must find the optimum condition for spray coating to get the best coated on the glass plate.
Oh, okay. And also, actually, I would like to know why the marble shape is give lower. I forgot that. Is not as good as the glass type.
For the photocatalytic efficiency, it's better, compared to glass plate. However, the TiO2 not attach on the surface perfectly like glass plate. Maybe different characteristic of glass. So that's why TiO2 from at the marble surface is easy to wash out compared to glass plate.
Yeah, that's why. Or maybe because it washed out and it will be inhomogeneously reacted with your substrate.
Yeah.
Okay. So you will try to overcome that problem. Okay, thank you very much. Any other question for the last three presenters?
Oh, Dr. Nino, please.
Yeah, Bapak Haryadi, maybe you want to ask something.
I think Dr. Nino has raised first than me.
Oh, sorry. Okay. Yeah. Thank you, Dr. Hari. So I want to ask to Dr. Rossi. So just want to ask your opinion about, have you ever think about to modify modify the titanium with the using with adding or using another actimetal in order to not to use UV light as a source, but we can use sunlight, something like that, because this application is actually good, but if we want to apply in the real situation, is difficult. I mean, there is a difficulty. We have to prepare the source of UV light, and of course we have to prepare the electrical. So if we use the sunlight, so it's maybe better we can put in the field, something like that. So have you, what is your opinion about that? Have you try to move not using UV and the UV light to sunlight, something like that? Is possible?
Yes, of course, it's possible. We can modify the TiO2 with another material, like maybe carbon-based material or Fe material. Fe also good catalyst material to improve the TiO2 under visible light activity.
But you haven't tried it yet in your life?
For current research, we try to modify the TiO2 with carbon-based material.
Okay, thank you. Dr. Reddy, please.
Okay, thanks, Dr. Nino, and thanks, Dr. Kiki. No, I just want to compare because I've done photocatalytic as well by using the carbon base, right? We got an order down to below 10 nanometers. We use a carbon dots, and surprisingly, because the ability to degrade is almost 90% for that one. I think that's a good challenge as well. I mean, if you try to use a carbon-based material for this one. But the thing is that for me, continuing the question for Dr. Nino, that's besides the materials as well, the particle size, will you consider as well? Because that's going to be significantly influenced also with the ability to absorb the photon when it used to be as a photocatalyst.
Yes. Okay, thank you very much. Yes, of course, we should consider the particle size of catalyst. And we know that nanoparticle is the best size to produce photocatalytic activity. But the further homework is, if we want to apply this technology in the real application, how to separate the photocatalyst material with the pollutant water. So that's why we try to create the immobilized photocatalyst material. Consequently, of course, photocatalytic efficiency will be lower than photocatalytic material. But I think we should find a win-win solution if we want to apply this technology to the real application. For the lab scale, of course, we cannot say another. We don't have another choice. Nanoparticle is better.
Yeah, I mean, the best choice is if using the carbon base, because when we use for the environmental, is even safer than compared with the metal one. Right?
Yes.
Yeah, I think that's why considering the resource for the photocatalyst, I think there's a.
But of course, we should consider the composition between carbon-based material and TiO2 material, because the position of carbon-based here not as photocatalyst material, but for the co-material, means that carbon has the ability to absorb not to decompose. That's why
Okay.
the difference between the photocatalyst and carbon.
Okay. My experience is different because the carbon itself seems like a type of as a semiconductor as well, because it
Carbon
has
dot.
about this carbon dot.
Carbon dot. Yes, it has a good catalyst performance.
Yeah.
But here we have another type of carbon-based material. We can say activated carbon. We can choose activated carbon because based on the economical point of view compared to carbon dot. Because if we want to produce carbon dot in a large scale, of course we should consider another point of view.
Okay.
Okay, thank you very much. So the question from Mr. Haryadi has closed our question session. Thank you very much for the fruitful presentation and also discussion. We will have a break until 3:15, and then you can join again with us in this room or the other room. So I would like to thanks to all the presenters and also the everyone who come in this room. And okay, thank you very much.
Thank you very much.
Thank you very much.
Thank you, everybody. Thank you.
Udah ada matiin suara Bapak nih.
is one of the most dynamic and innovative companies within the Berke Group. The Berke Group consists of over 35 operating companies in over many industries, including technology, infrastructure, and engineering. Berke America has been in business for over 17 years and has established itself as the major player in the research and the chemical analysis industries. Its customers include many bodies in the government sector, as well as large corporate entities. And its industries include food research, agriculture, petroleum, chemical, environment, and clinical research. We believe that Berke America is very well suited to meet with all stakeholders, support the quality of life, and to improve it in Indonesia. We fully support Berke America to meet with all stakeholders and form partnerships to improve the quality of life of people in Indonesia. is one of the most dynamic and innovative companies within the Berke Group. The Berke Group consists of over 35 operating companies in over many industries, including technology, infrastructure, and engineering. Berke has been in business for over 17 years and has established itself as the major player in the research and the chemical analysis industries. Its customers include many bodies in the government sector, as well as large corporate entities. And its industries include food research, agriculture, petroleum, chemical, environment, and clinical research. We believe that Berke is very well suited to meet with all stakeholders to support the quality of life and to improve it in Indonesia. We fully support Berke to meet with all stakeholders and form partnerships to improve the quality of life of people in Indonesia. Is one of the most dynamic and innovative companies within the Berke Group. The Berke Group consists of over 35 operating companies in over many industries, including technology, infrastructure, and engineering. Berke has been in business for over 17 years and has established itself as the major player in the research and the chemical analysis industries. Its customers include many bodies in the government sector, as well as large corporate entities. And its industries include food research, agriculture, petroleum, chemical, environment, and clinical research. We believe that Berkepribadian America is very well suited to meet with all stakeholders to support the quality of life and to improve it in Indonesia. We fully support Berkepribadian America to meet with all stakeholders and form partnerships to improve the quality of life of people in Indonesia.
Okay, good afternoon, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Welcome to the parallel session of ISAF 2021. My name is Hosi Arutanti. It's my pleasure to be a moderator for this session, Environmental and Analytical Chemistry and Clean Energy Production Technology. In this session, we have 5 distinguished speakers. Before we start the session, I would like to inform some of the technical rules. First, this session will be divided into 2 parts. The first part will be 3 speakers, will be present the material, and after completion, followed by the discussion session. And then we continue to the second part for 2 speakers. And after they finish present their material, we continue to the discuss session. Here, each presenter has 10 minutes to present the material, and we will play the recorded video, which has been sent to the committee. And a speaker who has not sent the video until the due date will be allowed to present as the last speaker live. Furthermore, here, Mr. Hendriana will transfer to the last speaker. For Mr. Hendriana, you attend this room. And during the presentation session, for the question, please write in the chat room or raise your hand. Okay, now I will start the parallel session. For the first speakers, please welcome to Ms. Leni Marlinda. Today, Ms. Leni will present their research entitled Improving the Quality of Lignite Through Addition of Vacuum Residue Using Slurry Dewatering Process. And the committee, please play the video.
Assalamualaikum warahmatullahi wabarakatuh. I am Yanwar Fasmawi Salman, student of Department of Chemical Engineering, Faculty of Science and Technology, University of Jambi. I will present about my research, improving the quality of lignite through the addition of vacuum residue using slurry dewatering process. In the world, coal was used as energy resources. So, in this research, have a background are the first, abundant reservoirs of lignite coal, and lignite coal has a low selling value. It goes by high water content and low calorific value on lignite coal. The formulation of problem from this research is how is the effect of temperature variation on the slurry dewatering process using vacuum residue on the quality of treated coal, moisture content and calorific value, and characteristic of treated coal, SEM EDX analysis and FTER analysis. Lignite coal is low rank coal based on ESTM classified with low calorific value and high moisture content. So, to improve the quality of lignite coal in this research using vacuum residue, where vacuum residue is bottom product from vacuum distillation in oil and gas industry process. To dissolution vacuum residue using petroleum benzene. This solution have ability to dissolution hydrocarbon compound. An upgrading process is a process to improve the quality of coal, especially lignite, from lowest calorific value to medium or high calorific value. And slurry dewatering is one of various types of upgrading process using oil media to improve quality of coal. And flow diagram from this research, there are 4 steps. The first is preparation, where coal was cold crushed and drying, and vacuum residue was dissolution with petroleum benzene. And the second step is slurry dewatering, where coal crushed and dried, mixing with additive solution. After that, process slurry dewatering using temperature variation between 130 degrees Celsius to 180 degrees Celsius. And mass of coal using is 100 gram and processing time 1 hour. After that, separation process is drying at 122 degrees Celsius for 1 hour. And the final analysis are calorific value, moisture content, SEM EDX, and FTER. And the result is, from the slurry dewatering process, accurate decrease on mass of coal, where from 100 gram initial coal to difference of mass on final coal, where the height has decreased, occurred at 180 degrees Celsius is 60.76 gram with percent yield 95.88%, and decrease on mass of coal indicate decrease on moisture content of coal. So, the moisture content after slurry dewatering process occurred decrease from the initial coal has moisture content 37.62%, and on final coal, the height has reduced water content occurred at 170 degrees Celsius with moisture content is 1.55%, or percentage reduced water content at 170 degrees Celsius is more than 95%. From this condition, decrease of mass and decrease of moisture content has an effect on calorific value, where increased calorific value occur, the height has occurred, the accurate increasing calorific value, the height has at 170 degrees Celsius, where from initial coal had with 3,662 calories per gram, and in the final coal or treated coal, have calorific value, the highest increase is 5,666 calories per gram. And for this calorific value, percentage increase calorific value at 170 degrees Celsius more than 45%. And some EDX analysis from the figure, it's seen accurate fill and code on this indicate where vacuum residue, filling and coating of coal pour. And from EDX analysis, we can see accurate increase percentage of carbon and decrease percentage of O, where from initial coal has a percentage of C is 73.15, and in final coal has 77.65%, and for O from initial coal has 26.54%, and in final coal has 21.31%. And from FTIR analysis, we can see accurate decrease of concentration of functional group were found for functional group on initial coal and 5 functional group and treated coal, adding one functional group or one functional group on treated coal. Where on initial coal was found OH, CH, CC, and CO, and adding CN on treated coal. Decrease on functional group of OH and decrease of percentage oxygen containing, it goes by decrease of moisture content. So from this result, process dewatering using vacuum residue improve the quality of liquid coal from liquid E to sub bituminous B in the final, where accurate increase calorific value and decrease moisture content, and increase carbon content and decrease oxygen content. Final, thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Mr. Januar. Okay. We continue to the second speaker. Please welcome Mr. Hafiz Prasetya. But for the session, Ms. Rizali will present the material. So for Mr. Rizali, please, the time is yours.
Thank you. I want to present about my paper, Development Concept of Horizontal Subsurface Flow Rain Garden Systems, Potential of Puribicus, Plans to Overcome Heavy Metals Contamination, FA and MN in Stormwater Runoff, presented by Rizali Noor, Nova Anissa, and Hafiz Prasetya. Next. Introduction. stormwater runoff carry pollutants and other harmful chemicals to rain garden technology was technical designed to be able to resolve the problem of stormwater runoff and possible to develop rain garden technology with a horizontal subsurface flow system. And then, a biofilter is a technology to improve water quality. To this research was conducted to combine horizontal subsurface flow rain garden using Fronticus plant, and then to increase its efficiency about that. Next, material and methods. You can see about picture. This research was conducted by draining stormwater runoff made scientific by adding a standard solution of iron, Fa and manganese, Mn, with a minimum purity of 99%. The iron concentration used in this study was 25 parts per million, and the manganese concentration was 15 parts per million. This runoff was channeled through a rain garden system with a continuous horizontal subsurface flow. This study was carried out under laboratory conditions, so it was ideal to understand the mechanism of heavy metal removal and compare it with controls. Yeah. This picture, the flow disposal was about 5 liters per day. The water flow passed through 5 reactors, which consisted of a rain garden reactor planted by Fronticus, with a distance between plants of 15 centimeters, with 2 replication and 1 control. No addition of Fronticus plants distinguishes this control. The reactor was made of wood with dimensions of 100 centimeters, 30 centimeters, and 35 centimeters. This reactor was a modification of the last reactor that has been reported it's utilized. Next. This is graphics. The results show that this Fronticus plant can grow well in the reactor. The growth of Fronticus can be seen from the increase in this heights. The height of Fronticus plant in each of the reactor was measured from the first day until 4th day. The initial height of plants used in the study is about 17.9 centimeters on average. Plant height differently increased in each of reactor. The growth of plant height in the rain garden reactor model is carried out to see the plants respond after scientific through stormwater runoff contaminated with Fa and Mn metals. This plant has a positive response, can survive and adapt it to these conditions. Next. With graphic, in this study, the decrease in Fa and Mn concentration was found above 70%. This number is smaller than those of Yunus and Prihatini 2018, Lang et al. 2020, Wulan et al. 2020, and etc. Next. The comparison of heavy metal decrease in this study others, you can see about table, percent removal, about Fa 71.3% and Mn 71.4% in this research 2021, and etc. Next. Result and discussion. The roots of the Fronticus plant with an extensive root cavity cortex cause the absorption process faster. Ion absorption in the roots occurs actively where ions from the epidermis get into and then are transported to the cytoplasm or root tissue cells through the epidermis into the protoplasm among root tissue cells, namely the cortex endodermis, pericycle, and xylem. There is Caspary band in the endodermis due to thickening field with separate, impermeable to water as it decays with cation and lignin in the lab, critical causing the accumulation of heavier particles in the roots. The presence of this Caspary band becomes a control on absorption of ions and by the roots. In addition, the roots of the Polonticus plant can also form a gelatin substance. This substance will bind the metal and then carry it into the root cells. To increase metal absorption, the root membrane forms reductase molecules. With the formation of gelatin substance and reductase molecules, it will be easier for metals to cross the root epidermis and enter root cells, resulting in high metal accumulation. This corresponds to the result of scanning electron observations on the root surface of Polonticus, which found iron flux on the plant root cells. The accumulation in the roots is also due to the active absorption of ions in the roots, so that metal ions are actively accumulated in epidermis. You can see about the pictures. And then, next. Conclusion. The horizon subsurface flower and garden model reactor with Polonticus plant reduce iron and manganese concentration with a percentage reduction of more than 70%. Then, the decrease in concentration is due to a complex process in the horizontal subsurface flow and garden, which includes a combination of environmental and biological physicochemical process. To the Polonticus plant used in this study had a positive response, was able to survive and adapt to stormwater runoff conditions with a concentration of iron of 25 parts per million and manganese of 15 millions. Next. Thank you for your attention.
Thank you very much for the presentation, Mr. Rizali. Because of today we only have 4 speakers, so I decided to finish all presenter and then the last part for discussion session. So for the third speaker, please welcome to Mr. Murianto. Mr. Muri will present electrocoagulation and activated carbon adsorption of MOCAF, modified cassava flour wastewater. For Mr. Murianto.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you to moderator for this opportunity. My name is Murianto from Research Center for Chemistry. Today, I want to present our study about electrocoagulation and activated carbon absorption of modified cassava flour or MOCAF wastewater. Okay, this is my outline presentation today. I will start from introduction, matter and method, then result and discussion, and finally I will close with the conclusion. MOCAF or modified cassava flour was produced from cassava through fermentation process by lactic acid bacteria. The MOCAF consists of stripping, cutting, soaking, fermentation, grinding, and also drying. The wastewater in MOCAF process is generated from the fermentation or soaking process of cassava chip. MOCAF wastewater contains a large amount of organic pollutant with high COD, chemical oxygen demand, total dissolved solid, total suspended solid, and also have the pH tend to be acid in the range 3 until 5. So this wastewater can lead to disruption of water quality or pollution. So the wastewater must to be treated before it discharged to the environment. Okay, this is the process. As we know, the common wastewater treatment for organic pollutants such as MOCAF wastewater consists of physical process such as filtration, screening. Also, or we can use the biological process like activated sludge, and chemical process using coagulation and population. But that process have some advantages that disadvantages that us need to rectify, long processing time, and also with chemical addition. So the electrolysis can be alternative to treatment of wastewater. Electrolysis is electrochemical using electrodes and electricity. The advantages of the electrolysis is the simple equipment required, easy to operate, and also without chemical addition. And the electrocoagulation is integrated to the coagulation process because in the electrocoagulation, hydrogen produce hydrogen to bubbling and floating the blocks. Electrocoagulation needs the electricity. Usually we use the electricity from, we call it PLN. But as we know, the sunlight is the potential for renewable energy. So solar panel can be utilized to electricity in electrocoagulation. Activated carbon is the absorbent that often used in the absorption process. For example, activated carbon can be used to treat the tofu industrial wastewater. So the objection of this research is to conduct the hybrid electrocoagulation using electrocoagulation and absorption method. Also, we investigating the effect of electrocoagulation and absorption to COD, pH, TDS, and also TSS. And then we investigating the activated carbon after the absorption. These are our material methods. Mock-up wastewater we collect from the small and medium interface in the Bogor, West Java, Indonesia, and we measure the composition. After that, we treat it with the electrocoagulation. With the chamber we use from glass reactor with the capacity 2.5 liter. The electrode that we use is the aluminum, and the distance between electrode is 3 centimeter. We use the electricity from solar panel. The process in the electrolysis is for 30 minutes, and then after that we collect the sample, we filter, and we analysis. After that we add the activated carbon in the variant of doses in 3, 5, and 10 grams per liter, and we conduct the absorption for 1, 3, 6, and 9 hours. After that, the sample we collect and we filter, and then we analysis. pH and TDS are measured by digital benchtop method, temperature by thermometer, total suspended solid and chemical oxygen demand we measure by according to Indonesian national standard. Okay, this is my result. Can we see in the table? One, the composition of mock-up wastewater before treatment. The mock-up wastewater contain COD around 8,000 and total dissolved solid in 1,000 and also total suspended solid in 1,200 ppm. The pH is around 5.7. You can see in the table after electrocoagulation, the pH in the mock-up increased to from 5 to 7. Also, the electrocoagulation can reduce COD up to 18% after 30-minute process. In this process, we can see that the solar cell can substitute the electric source for electrocoagulation. And then for the sample, we can see for pH and COD is still high, so we conduct the absorption after the electrocoagulation process. This is the result for the absorption process. We can see in the feature after absorption, the sample, the pH increase from 7 to 8. Also, we can see the increasing the absorption time can increase the pH of mock-up wastewater. And the COD in the second picture, we can see the we can reduce the COD from 8,000 to 4,000 after absorption. So the capacity COD removal is around 35% after absorption, or 47% for the absorption, electroabsorption and absorption. This is the figure for TDS and TSS. You can see in the doses of activated carbon in 10 gram per liter can reduce the TDS and also TSS or in the mock-up post water. The TSS can obtain to 500 milligram per liter, and the TDS can reach the 1000 ppm. Okay, this is the FTIR analysis for the activated carbon in use after and before the process absorption. We can see there is the difference spectrum in the peak at 1,400 until 1,600, and in 1,700 until 2,200. The difference peak in this picture can prove that the activated carbon absorb the pollutant in wastewater. Okay, this is my conclusion for presentation today. The solar panel for the electrolysis process, increasing the pH of mock-up water and reduce COD, TDS, and also TSS in mock-up water. The optimal condition for the absorption with activated carbon is when we use the dose and 10 gram per liter for 6 hours. When we combine the electrolysis and absorption, we can remove the COD until 47%. And then the electrolysis and absorption hybrid method effective to reduce COD, TDS, and TSS, and also increasing the pH of mock-up water. So this process can be used as the organic wastewater treatment. Okay, that's all our presentation. Thank you for your attention, and I will back to the moderator.
Okay, thank you very much for Mr. Murianto. Next, we continue to the fourth speaker. Please welcome Ms. Atika Syahida. Ms. Atika will present performance test of negative ion plasma as air purifier to degrade volatile organic compounds.
Good afternoon, everyone. I'm Atika Syahida from the Department of Chemical Engineering, Faculty of Engineering, Universitas Indonesia. I want to present our study about performance test of negative ion plasma as air purifier to degrade volatile organic compounds with case study for ethanol and toluene. Based on data from WHO in 2014, acute respiratory infection is still one of the biggest causes of death in Indonesia, reaching 5% of the total death cases. Moreover, based on data from Ministry of Health of the Republic of Indonesia in 2020, tuberculosis sufferers in Indonesia in 2019 reached 540,000 people, and acute respiratory infection dominates morbidity in toddlers and causes the death of around 4 million children under 5 per year. These problems are caused by indoor-air pollutants that consist of volatile organic compounds, bacteria, particulate matter that have been less than 2.5 micrometers, so that an air purification unit is needed that can clean indoor air pollutants. However, the air purification units on the market are still quite expensive and consume a lot of energy. So the solution is use negative ion plasma-based air purification unit that is capable of degrading volatile organic compounds or VOC. Why do we use negative ion plasma? Because first is it's capable of producing highly reactive ions and oxidizing radicals in large quantities, and also because the initial investment and running costs of negative ion plasma are cheapest than other VOC treatment methods. And based on the result of research conducted by Vance et al. In 2011, which can be seen in the table on the left, ethanol is one of the indoor pollutants that is always measured in various rooms. In addition, based on indoor air quality research at several points in a residence in Spain, conducted by Gallego et al. In 2009, it was found that as many as 17% of 113 VOC detected were aromatic hydrocarbon compound, one of which was toluene. Therefore, in the study using a case study of ethanol and toluene, to note that the VOC threshold value based on regulation of Ministry of Health of the Republic of Indonesia is 3 ppm for 8 hours, while the threshold value for ethanol is 1000 ppm and for toluene is 50 ppm. The following are the objectives of this research. This research is aimed to obtaining the relationship between the effect of contact time and fan speed on a negative ion plasma ability to degrade VOC. Next is methodology on this research. This research is still with regulatory review, then manufacture of the air purification prototype, followed by equipment characterization and negative ion density measurement, then make standard curves of ethanol and toluene. After that, testing the ability of negative ion plasma integrating 1500 ppm ethanol and 6 ppm toluene by doing two variations that are varying the contact time from 1 to 5 hours and varying the fan speed by varying the input voltage by 7.5 volt, 9 volt, and 12 volt. After that, the sample was tested using GCMS right after the contact time ended. Then if there is a decrease in the peak area of ethanol and toluene, data processing is carried out and then analyzed and concluded. It also can be seen in the following slide, the dependent, independent, and controlled variables in this study. The following is prototype in this study. The prototype is in the form of a cube and is made of PVC pipe and mica. This prototype is equipped with two fans located on the top and inside the prototypes. The top fan serves to draw and free air as a background gas and clean the pollutants inside the prototype after testing. In contrast, the fan in the prototype helps to circulate the VOC sample throughout the prototype room. The fan inside is what will vary the speed. Then in the prototype, there is also a plasma generator with an input voltage of 12 volt, an output voltage of 2 to 6 kilovolt, and electrodes made of carbon fiber. In addition, this prototype is also equipped with an air quality meter to measure the concentration of ozone and TVOC. The following are the characteristics of the tools used in the study. It can be seen in the following table that the density of negative ions produced by the plasma generator is 8 to 12 million ions per meter cubic. In addition, very little ozone is formed, as much as 0.011 to 0.024 ppm. Next is result and discussion. Here are the ethanol and toluene degradation test results on the effect of negative ion plasma contact time on concentration of ethanol and toluene. It can be seen in the two graphs on the following slide that there was a significant reduction in the concentration of ethanol and toluene for 5 hours. However, it can also be seen in the graph on the left that the reduction in ethanol concentration from the 4th hour to the 5th hour is very small, only 0.01%. Therefore, the degradation of ethanol using negative ion plasma was effective for 4 hours with the removal efficiency value reaching 99.94%, and the final ethanol concentration of 0.97 ppm, while in the Tolwen case study, from the 4th hour to the 5th hour, there was a decrease in concentration of 6.79%, so that the degradation of toluene using negative ion plasma was effective for 5 hours, with a removal efficiency value reaching 99.77% with a final concentration of 1.30 ppm. Based on the image on the following slide, for the effect of one speed on the removal efficiency of ethanol and toluene, it can be seen that the larger the font voltage value, which analogously is the larger the font speed, the greater the removal efficiency of ethanol on the left side and toluene on the right side. This shows that the font speed significantly affects the performance of negative ion plasma in degrading ethanol and toluene. This is because the presence of a font can help increase the frequency of ethanol and toluene gas in contact with negative ions or active species produced by the plasma generator. And this is the TVOC degradation test result. Based on the graph of the following slide, it can be seen that total VOC concentration in the ethanol case study decreased by 91.52% for 90 minutes, with the final TVOC concentration of 0.49 milligram per meter cubic. Meanwhile, in the toluene case study, the TVOC concentration decreased to 90.24% for 120 minutes, with the final TVOC concentration of 0.55 milligram per meter cubic. The two case studies that have been conducted show that negative ion plasma can reduce TVOC concentration until the indoor air quality reach second level, or it is good value based on the level of indoor air quality according to the RNSS. So the conclusion in this study is, first, negative ion plasma can be applied well as an air purifier to degrade volatile organic compounds, especially ethanol and toluene. And then the longer the use plasma negative ions, the greater the value of ethanol and toluene removal efficiency. And the blowing speed of the fan affects the ability of negative plasma ions to degrade VOC, where the greater the fan speed, the greater the ethanol and toluene removal efficiency. This is our references. Thank you for your attention.
Okay, thank you very much for Ms. Atika for a nice presentation. Now I will open the discussion session. If there are any question, you can write on the chat room or raise your hand. Okay, first, I would like to read the question from Mr. Yan Bagus Prakasa for Mr. Rijali Nur. The question is, what are the advantages of rain garden technology with the horizontal subsurface concept? Or Mr. Rijali, please answer the question by on your video. Hello, Mr. Rijali.
Okay, thank you. This technology was very effective in reducing the effect flow rate of stormwater runoff and reducing flooding. Thank you, Mrs. Melly, for your question. This research can reduce the iron and manganese compounds for the remaining 30% of iron and manganese may still be stored in soil media. Sorry, the study didn't see the concentration of heavy metals in soil media. Measurements are only carried out on effluent water. Thank you very much for Mrs. Melly. Maybe in the future we will also pay attention to the amount of contaminants in the media. Thank you.
Okay, thank you for Mr. Rijali. Next, I will continue to the next question from Miss Amanda for Mr. Murianto. Your AC show a promise as a water remediation as wastewater from mocha production. What is the source of activated carbon? And do you consider the reusability studies to investigate the effectiveness of your treatment for multiple use in the application? For Mr. Murianto.
Thank you to Ms. Amanda for the question. Actually, we use the commercial activated carbon from coconut shell. So we just use the commercial activated carbon, and for the repeatability, fortunately we didn't conduct that process, but I think it can be done because some research say that activated carbon can be used after the activation again.
Okay, thank you very much. The next question from Ms. Yani Meliana to Ms. Atika. Why the set time for contact plasma only till 5 hours? Ms. Atika?
Yes. Okay. Thank you for the question, Ms. Yani. We chose this time as 5 hours because generally the threshold value of toluene and ethanol in the air is 8 hours, like that I showed before in my presentation. So that's why we chose 5 hours, because we want this pollutant degrade faster than the threshold limit. I think that's it.
Okay, thank you. So, Ms. Atika, could you explain why the ethanol is better than toluene, means that faster to remove compared to toluene?
Yeah. It is because toluene molecules has a stronger than more complex chemical bond than the ethanol molecules, and the CC bond of benzene in toluene has a bond energy of 5.4 electron volt, while the OH bond energy in ethanol has a bond energy of 4.8 electron volts. In addition, the value of the CH bond energy of benzene in toluene also greater, that is 4.6 electron volt, while in ethanol it is 3.7 electron volt. So in ionization energy, or IE, or bond energy, is the amount of energy expressed in the units of electron volts, which is required to effect the release of electrons from molecules or atoms. So because of that things, because since the energetic electrons, negative ions, and active species are generated using the same plasma generator in both case studies. So in this case study, toluene, which has higher ionization energy, will take longer to break bonds in the toluene compound. So that's why ethanol have short time than toluene.
Okay, thank you very much. And is there any question? Or you can raise your hand. I have a simple question for Mr. Yanwar. Hello, Mr. Yanwar.
Yes, Miss.
For calorific value, okay, why it's decreased after 170 degree? Could you explain?
It caused by decrease of moisture content on the lignite. So after that, calorific value from lignite was increased.
Yes, I mean that from 0 to 107 degrees Celsius, the calorific value increased, but after that decreased.
It caused by decrease of vacuum residue, on lignite. So the calorific value was decreased after 170 degrees Celsius.
Thank you very much.
Thank you, Miss.
Maybe, is there any question? I would like to ask Mr. Rojali. Mr. Rijali. Hello, Mr. Rijali. Mr. Rijali. Hello, Mr. Rijali.
Yeah.
Yeah. Yeah, your research is interesting for me. So I would like to ask, in your case, you try to modeling the vertical flow chart, vertical flow reactor. How about the horizontal? Have you compared which one the better between the vertical and horizontal?
Okay. This research can be about the future for remedying the safety of iron and manganese. And then maybe the future will be also pay attention to the amount contaminants in the media.
So for now, you have not checked for the horizontal reactor, right?
No.
Okay. Thank you very much.
Yeah.
Is there any question? Okay. From, I don't know who is co-host D. The question is, first, what mechanism is happen when plant root do creating the metals? Did you measure about functional group or something from active side of the root? Hello, Mr. Rijali. Could you hear me?
Okay. Thank you, Mrs. I think the mechanism is not okay. Has not been investigated further. This has not been investigated further.
Okay, thank you very much.
Yeah, thank you.
Maybe for another question. Okay, if there's no question anymore, I will close the session. But
there is one question on the chat room, I see.
Okay. From chat room, from co-host D.
Co-host.
Ms. Razali have answered this question.
Okay.
If there is any question, I will close the session. After I close the session, please do not leave the room. The committee will transfer all participants into the main room for the closing ceremony of ISAC 2021. So I will close the session. Thank you very much and see you again on the next occasion. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih semua. Thank you.
Bu Mary.